Hello and welcome. This is our seventh Share Your Green Design Masterclass. Share Your Green Design is a digital ecosystem of exemplary case studies, research, methodologies, and ideas that showcase sustainable architectural design from all around the world. Our mission is to substantially reduce the industry's carbon footprint by providing architects, engineers, and all construction professionals with the knowledge that they need. Masterclass is a space where we invite top experts on very specific topics related to sustainability in the built environment, decarbonization, health and well-being in buildings, and much more. Today, our special guest is David Trujillo. David has over 25 years' experience in the structural use of bamboo. His work with bamboo has been both academic, with 50 publications in the field, and practical, as he has led and fostered the development of ISO standards on the topic. David currently works as an assistant professor at Coventry University within the Center of Agroecology, Water and Resilience, and also as the head of biomaterials at Atelier 1. David is the head of the UK delegation to ISO Technical Committee 165 Timber Structures and the UK's designated expert to Working Group 12, Bamboo Structures from the same committee. In this masterclass, David will showcase this fascinating material, which, in his words, is possibly the most sustainable structural material available to us. So why don't we use it? This masterclass will outline the characteristics of this material, its potential, as well as its limitations, and the efforts being undertaken to enable its adoption as a mainstream material, specifically the development of the ISO standards for bamboo. As usual, we'll have Q&A session after the presentation, so please post all your comments and questions in the chat on whichever platform you are streaming from, and we will go through as many as we can. We will record this session and post it later in our channels for your review. So over to you, David.
Thank you. Thank you very much, Bethania. Thank you for that introduction. So just briefly about myself, I think things have been mentioned. I was educated on my undergraduate level in Colombia and then came to the UK and have done my postgraduate education here. That photo of me is when we had a shipment of bamboo arrive at our university some years ago, and that was my face of delight. Bethania has also mentioned the roles, so I'll skip through this slide. And we'll get straight into the matter of bamboo. So the issue to note about bamboo is a giant grass. It's part of the Gramineae family. It is not a tree. It is native to all continents except Antarctica and Europe. And there are over 1,600 species in the world. Now, when I say it's native, it doesn't mean that it can't be grown in Europe, because it can. It's just that there are no endogenous species. There are many varieties. Some of them are small and some are huge. Interest in construction has been mainly focused on the huge ones, shall we say. So here I've got a photograph of a culm that was, that's the name of the stem in bamboo, that was over 16 centimeters diameter. So that was really, really big culm. Bamboo reproduces mainly in a vegetative manner. So it grows by spreading outwards through this network of roots that expand underground. And it can create this really large network of up to 100 kilometers in a hectare. Once you have an established plantation, it continues producing stems or culms regularly. And these stems grow very, very quickly. They can grow up to 25 or 30 meters in as little as 3 months. So it grows phenomenally quickly. It only undergoes primary growth, which means it only grows upwards. It doesn't, like trees, become wider. So this very big culm that's in that photograph isn't from an old piece of bamboo. It was that it came from a plantation that had the ability to produce stems of this size. And then it's customary to harvest it somewhere between 3 and 6 years when it's at its optimal characteristics in terms of strength, stiffness. So one of the key things about bamboo is that because it's a quick growth, it's a rapidly renewable resource, and it has a potential to substitute other forest products, which could reduce the pressure on primary forests. By primary forests, we mean the forests that humans have not interfered with. So due to continuous production of colms, we only harvest some of these stems. We don't clear cut like we would with trees. We just extract some of the mature ones. That means that some of the stems remain, which means we disrupt less the livelihood of the creatures living in the forest. It's very easy to harvest these stems because you don't need heavy, big machines, because these stems are relatively small. They can be carried by 2-3 people out of the forest. So the equipment they need to have, the machines they need to have, not a low cost. So it means that people who have a forest of those don't have to have big capitals. And these stems, if we did not harvest them, about at 10 years, they would rot and die in the forest. It's part of a normal cycle. And as they rot and die, these stems, the carbon associated to the stem would return to the atmosphere. So if we instead disrupt that natural cycle and take the stem out of the forest and make it into a durable product, and nothing as durable as buildings, and so that's why buildings would be ideal, we would be using the forest as a carbon, it's a sink. We're helping the carbon cycle of the forest by disrupting it to act as a further sink. So what's one of the things that's very appealing about bamboo is that it has the potential to be a great carbon sink. It has other really interesting characteristics. Its root system helps to stop erosion. It helps regulate the water cycle. A lot of the carbon sinking is happening at the soil level, so that's where it needs to be considered. It doesn't need many pesticides or fertilizers. It can act as a windbreak, and it can restore degraded or polluted soils. So bamboo has a lot of powerful qualities in terms of its role in the environment. We did a study where we considered the case of Colombia, and we compared it with common forms of construction using brick and concrete. And so here we have considering carbon sequestration. The carbon footprint per square meter of construction could be actually considered negative in some instances for bamboo versus the other technologies. So the reality is that bamboo has many interesting environmental properties. How can we use bamboo? We can use it as a stem itself. We can split it into strips. So people call these split strips or slats, these things that are extracted from the bamboo. You can flatten it, what we call in Latin America, esterilla. And this latest product I've discovered, which you get these splits and strips, and they put a dowel through them, and they make these boards. And currently, these are the things that most excite me about using bamboo. It is, the technology that most excites me. And then you can also generate something called engineered bamboo products, which we'll also talk about briefly. So there are two main engineered bamboo products. They're not the only ones, and there are people developing other technologies all the time. But these are the two main at the moment. One of them is called scrimber, and the other one is called laminated bamboo. The way they're made is slightly different. I'm going to elaborate a bit about how laminated bamboo is made. So what happens is you cut the bamboo into little strips, and then you glue them together to make a board, and then you glue the boards together. And then you can make products like this one. Now, interestingly, this one, you can see that it's being located outdoors. And that's one of the characteristics of engineered bamboo, is that you can place it outdoors. We will talk about bamboo colms should not be placed outdoors. And I hope there are quite a few architects in this meeting who will pay attention to this point that I will reiterate many times. One of the things that's really exciting about bamboo is its mechanical properties. So this is based on research that we've done at Coventry University for one species. This is a species native to Colombia called Guado angustifolia. And what I've done here is I've given you some properties. So this is something we call the mean strength. So that's sort of the average of the strengths. That gives you a number, say 82. This is in bending. And then what we use in structural design is we're cautious structural engineers, so we don't use the mean strength, otherwise 50% of our buildings would fall down. We use a much reduced strength, which is called the characteristic strength, which is roughly the 5th percentile. And that number brings it down from the average to about 50. So this is newtons millimeter squared or megapascals. And that places it in the same ground as pretty impressive pieces of timber. For those of you who are familiar with timber, this is a very good oak. Okay, but oak takes about 80 years to grow. So we're talking about a material that most properties are similar to those of oak. Some are better. So to maybe compare it to materials we're familiar with, let's see the strengths and weaknesses of the mechanical properties of one species of bamboo. So if you take tension parallel, it's about a third of the strength of steel, of structural steel, but it weighs a 12th. So bamboo is incredibly strong in tension, and it's one of the things that people have always found astonishing about it. It's how strong it is in tension. But it's a property it's really hard to exploit, and we are still trying to think of ways to use that great characteristic. If we look at bending, as I said, it's stronger than oak, and it's got a similar sort of strength-to-weight ratio to steel. In compression, when you're crushing it, it's stronger than most timber species, and it's comparable to a high-strength concrete. But remember, concrete will weigh 4 times more. Okay, in terms of stiffness, this is a really interesting point, because people always say, bamboo is very flexible. And it's apparently flexible because it can bend very far before it breaks. And that's why people say, it's very flexible. But in what we engineers refer to as modulus of elasticity, this property here, it's actually stiffer than many hardwoods. It's half the stiffness of concrete, but the stiffness of concrete is slightly elusive because it cracks and so forth. And it's about a 12th of the stiffness of steel, which is a very stiff material. But remember, steel is 12 times stiffer. So it's not bad stiffness. Then we go to some properties that are not great. Shear, it's okay, it's shear strength, but when we use it as a culm in the round shape, this property becomes problematic, and that is because bamboo tends to crack or split. And then we have a property that it's tension perpendicular to its fibers if you're trying to pull it apart, and it's like softwood. So we've gone from a material that is phenomenally strong in one direction, tension parallel to fibers, to not great in another direction. And that's a really important thing to bear in mind. Bamboo is a very anisotropic material. How can we build with bamboo? Well, I'm going to focus on ways we can build with culms. When you have engineered bamboo, you can build in the same way you could build with timber. So, you can just look up the possibilities. But let's talk about building with culms. This is a technique that natives of Colombia used to use to make bridges. This is a modern inspiration on that. This is a bridge designed by architect Simón Vélez. What's very interesting about this bridge was made in China, but the architect was Colombian and the builders were Colombian. But the Chinese found it very interesting building and a building technique, and they were very inspired by it. This is a community hall / church in Colombia. This is a clubhouse in Colombia that's been standing from the 1990s. It's still in a very good condition, and that's a very important thing to bear in mind because it's been around for about 30 years. So it evidences that in the right sort of circumstances, we can make bamboo durable. But that's a very important point. bamboo toll booth. This is a gymnasium in the Green School in Indonesia. And this was designed by the company I work on a part-time basis with, Atelier 1, alongside architect Ibuku, and was also helped along by master builder Jörg Stam. I think you will agree with me, it's a very beautiful structure. This is another building in China designed by a Colombian architect. This is Mauricio Cárdenas, who designed this hall for Inbar, for the Horticultural Expo in Beijing. One of the things I really like about this building is that it's an example of a bamboo building in a location that has seasons. Many of the bamboo buildings I've shown you earlier are for tropical locations, but Beijing has seasons, and so you can imagine it in an enclosed environment that could be anywhere in subject to seasons. There is a technique used in bamboo which we have developed in Latin America, which is called bareque. The more modern word we are promoting is composite bamboo shear walls. If you ever watch the film Encanto, the part of the house is made in this technique if you watch carefully at the details. Now, this technique has been exported to other parts of the world, and it's been introduced it was always present in Ecuador and Peru, but the first standard that was developed for this technique was developed in Colombia. And then it's been introduced to Mexico, Costa Rica, and more recently, the Philippines. And this is a photograph from a very big and interesting project called Base Bahay in the Philippines, where they're promoting this as a typhoon-resistant housing, not just earthquake-resistant housing. And you'll say, well, that's not fun. I can't see the bamboo. And that's deliberate. And that is because bamboo is not particularly durable when exposed to the elements. That's the second time I mentioned that in today's talk, and hopefully I'll mention it more times. And one of the things you'll take away from today's session is that bamboo is not very durable if exposed to the elements. Okay, this is a picture of that same technique being tested for earthquakes in Colombia, in La Universidad de los Andes. It was a two-story version, was subject to a series of tests on a shake table. In the end, the shake table wasn't able to destroy it. They had to just destroy it with a sledgehammer. So it's a very earthquake-resistant technique. Okay. I flew through that section because I wanted to set sort of the context of how we can build with bamboo. The problem is, how can we use more of it? So we know we have this material that is strong, that has many qualities from the environmental point of view. So how can we get more people to use it? So back in, I think this 2017, I gave a talk where I presented this vicious circle. We have a problem that we have no codes and standards, so people can't specify it or design with it or teach it. So there's little demand, and because there's no demand, why should we research it? And because we don't research it, there are no codes and standards. So I felt that we had to break this cycle. One starting point is to research it, the other leading to more codes and standards, so that everyone can specify it, design it, or teach it, and eventually we create the demand for the product, making it a virtuous cycle. So let's see what it takes to make bamboo a mainstream or conventional material. So I've been thinking about this and what it would take to make a material to be mainstream or conventional. The first thing, it needs to be readily available. It needs to be available in the market through a reputable and trustworthy supply chain. You don't think twice about the rebar you're going to put in your concrete frame, because you know there's a supply chain that makes sure that whatever you buy is of a good quality. Reliable. We need mechanical and physical properties that we know will work. We're not thinking it'll take this load and actually will take less. It needs to be well understood. We need that most structural engineers or other building professionals know how to use it. and there is a consensus of how it can and should be used. We know things that steel can do, or concrete or timber, and we agree upon them. We don't have an expectation that they do something they can't. And it's legal to use, and we need national legislation as well as codes and standards to support its use. So the work around standards that I have been doing works towards trying to make sure we have a reputable and trustworthy supply chain. We have reliable mechanical properties. In a certain way, deals with know how to use it and a consensus of how it can be used. And that's why I got involved with the topic of standards. So since 2013, I worked with INBAR, which is the International Organization for Bamboo and Rattan, in trying to restart work that had been initiated at the beginning of the 21st century around ISO standards for bamboo. And we started working group 12. And then in 2015, we said, well, we need to support this working group with some more work. And we created something called the INBAR Task Force for Bamboo Construction that would help the development of these standards. And since then, we have developed 5 standards, and there's a 6th one in process, and there's some others that are in earlier stages. So we have 3 standards for bamboo culms. One is the one I'm going to talk most about, which is structural design. We have one for tests for determining physical mechanical properties, and we have one for grading, which I'll just briefly talk about. And we have 2 for engineered bamboo, and they are mainly focused on the testing of engineered bamboo. There is this one that's being currently developed about specifying how the laminated bamboo product should work. So these are available. In fact, these first 4 are, from anyone who's listening to me from the UK, they are already British standards. So you can buy them from British Standards online as BES and that name afterwards. There are codes and standards from across the world. The reality is, if you look at this chart, that many of these don't tick all these boxes. They don't give you mechanical properties, or they don't tell you how to derive design values, or they don't give you how to design beams or columns or connections or shear walls or any grading. The one that comes closest to ticking most of these boxes was one developed in 2010 in Colombia. And then the next one of this list that comes near to ticking all these boxes is the ISO 22156. So the reality is, though, there are some standards out there. They're not very useful, with the exception of these 2 I've got in bold. For columns, as I said, we have these 3 standards. And the idea is that they fit into a suite of ISO standards for columns, where we have product specification, we have material testing, and we have a means to determine characteristic values. We didn't want to write a standard around some statistical methods for bamboo. That would be possible to just copy and paste the approaches used for timber. So we said, let's make our life easier, and we borrowed some timber standards for things that are not unique to bamboo. And then with that, we were able to create a structural design standard. And for that, we also would feed ourselves from other timber standards that we felt were appropriate and that we could borrow. Here is ISO Committee TC165. In 2019, we were in Colombia visiting a bamboo bridge. All these people were sort of like skeptical. Can you really build with bamboo? So we took them to look at this bridge so that they could see what you could do with it. Okay. I don't want to dwell too much about this particular standard. It's, for me, was a very important thing to put in place. I was a project leader for this standard, and it was about arriving at ways of grading bamboo. And we created some definitions around what was visual grading, machine grading, and other things that I'm not going to explain too much about today. It's not a prescriptive procedure for grading of bamboo. It is a framework. It tells you, if you're going to grade bamboo, this is what you should consider. More importantly, if you're going to write a standard for grading bamboo, this is what you should consider. It creates possibilities of other things. And it tells people, if you are going to write a standard about grading bamboo, remember the things that you need to consider. So you need to think about insect and fungal damage, about cracks, about diameters, wall thicknesses, and a sort of other things that we need to know about a column. And it outlines how it could potentially work. So, you could check your bamboo for certain things like taper and bow and ovality that doesn't have insect damage and so forth. And if it passes, you can say it's structural quality. And then you can assign it to a subgrade, say, by assigning by diameters. And if it meets that diameter, you've got it to grade. So it's a really simple standard. But the thing is, though it seems trivial, we're still not systematically applying this. There's still not a systematic definition of how internationally bamboo should be graded. Is the diameter at the base? Is it the diameter at the top? Is it the average diameter? And so there's still work to be done, and I'm hoping to revise this standard. But part of the grading could be as simple as just measuring diameter and then storing them in a way like I've shown here. There are some other really interesting possibilities of how to grade bamboo that I'm not going to elaborate in today's talk. I don't want to bore you. What I did want to talk about more is about structural design with bamboo. Now, let's start talking about the pros and limitations of bamboo, and particularly bamboo columns. So pro, as we've mentioned, it's got very low embodied carbon. It has many other sustainability qualities. Its shape, the fact it's a hollow cylinder, makes it a very efficient shape. It's not only a strong material, but it's a strong material placed in a very efficient use. So we arrive at a section that is strong and quite stiff for the amount of material you've got available. That results in light structures. I think it can make very beautiful structures, and it's versatile. It's temptingly easy to build certain types of structures with bamboo, which is fun. And so that results in it being quite easy to use for some applications. Against it, the cons, it has poor natural durability. So let me explain this, because it's a really important concept that I must insist. Some architects love seeing bamboo so much that when we point out to them this is a bad application, they don't want to listen. And it is that trees, when they grow, they undergo a process by which they accumulate naturally occurring toxins in a part of the tree called the heartwood. And this part of the tree, when we harvest it, has natural durability, some species more than the others. In bamboo, that phenomenon doesn't happen. So it doesn't have a location in the stem where it is accumulated over the years naturally occurring toxins. So if exposed to the elements, it will rot. If it's not chemically treated, it will be eaten by insects. So that is a really important architectural concept to appreciate about bamboo. The other thing to bear in mind about bamboo, in its natural column shaped, the hollow round shape, it's really hard to connect. And the shape also tends to be associated with a tendency to crack and split. And it is one of my greatest concerns about building with bamboo columns, is this natural trend to crack and split. As engineers, the more we work with bamboo, the more we realize that this thing of connection engineering is fraught with complications. And many people who've been working with bamboo don't realize how complex this is, and sometimes they don't even appreciate that they don't know they don't know. The other thing that happens when you have a circular hollow section is that it has poor fire resistance, because it can't exploit techniques like timber has, that is the charring rates, which is that wood burns from the outside inwards. And if your section is large, then you're going to have good fire resistance, good fire performance. But because bamboo is hollow, it burns from the outside inwards, and very quickly you're left with nothing. So ISO 22156 is a structural design standard which addresses these things about bamboo. It applies to the design of bamboo structures whose primary load-bearing system is bamboo round columns or shear panels made with the bareke system that we mentioned earlier. We have recommended that it's limited to 1 and 2 stories, residential, small or commercial, and light industrial buildings not exceeding 7 meters in height. We have not specified what 7 meters is. Is that to the ridge or to the eave? That, I suppose, is down to interpretation. Why have we been so strict about height, particularly the 2-story building? Because we're worried about the fire thing. And I can elaborate a bit more on that later on. And we only covers mechanical resistance, serviceability, and durability of bamboo structures. And we allow people to use different approaches of design. We can use partial safety factors or allowable stress. It permits something that we inherited from an earlier version of the standard, which is something called design based on previous established experience, which was we allow for the use of traditional bamboo techniques, provided that you meet certain rules about them, or design assisted by testing. So what does ISO 22156 make it different to, say, a timber standard? Well, we have written it in a way that it requires you to think about this annoying characteristic that bamboo columns have, which is the tendency to split longitudinally. So I've got an image here of bamboo splitting, and we've embedded into the structural design ways to address this. One of them is structural and member redundancy. So we're not going to design structures that rely on one single column to do a lot of work, because if that one split, then we could be in a situation where we're in trouble. We should also design them for replaceability. Should a column split and we decide that it's no good, we can't use that column any longer, then we must have a way to replace that column easily. We've introduced the concept of several classes, which is similar to the one contained in Eurocode 5 for timber. We have outlined something called use classes, which I'm going to elaborate about. We have incorporated pretty recent research around the behavior of high temperatures. We also outlined some things to think about fire. We've mentioned issues around maintenance and inspection and make that easy to make it possible. We've outlined how you could go about designing for connections, and we've included the light cement bamboo frame or the composite bamboo shear wall or the bareke technique. So we come back to this topic of durability. So we've said, if you want to use bamboo columns, you can use it in one of these 3 environments: interior dry environments, interior occasionally damp situations. So that would be something behind cladding that might get a bit of dampness in a very strong storm or something. And exterior above ground protected from ultraviolet rays and rain. If you put it exterior, and not protected from ultraviolet rain, then you can expect a design life of less than 5 years. Any of these other situations, in contact with the ground, fresh water, etc., then you're going to have very limited durability. This is something we've built into this standard. We want to reiterate that please use bamboo properly, because every time you do it badly, you damage the material's reputation. So in previous documents, we've made a schematic view of where bamboo performs well. One of the ways to realize where bamboo performs well is, unless you have an impermeable barrier, you trace this 45-degree angle. And if your bamboo, from the edge of the roof, if your bamboo is hit by this 45-degree angle, then it means your bamboo is in a location where it's going to have limited durability. So that's sort of 5-year durability location. So we can have very good durability if we're up under the roof, if we're behind a barrier, and if we are below this 45-degree angle. Anything else, you can have limited durability. To stress this point, we have, I took a picture of this weird looking building in Bogota in Colombia, where you can see a piece of bamboo under a roof. It's in a very good condition, and then it gets exposed to the elements outside of the roof, and it starts degrading. And the degradation that happens when bamboo is exposed to the elements outside is the skin. You lose the skin, so it becomes a lot more permeable to water from the outside. You tend to develop a lot more cracking. So these mechanisms that happen deteriorate its strength and load-bearing capacity. We have a section on connections. We've even postulated equations for some types of failure modes that could be happened if you put a dowel through them. Recent work I've done at Atelier 1, we've identified these 3 failure modes. These equations contain what's called failure mode A, are pretty good predictors, albeit conservative ones, provided that you don't put dowels in consecutive dowels in a single line. And this doesn't account for the technique of filling in with mortar, which we didn't cover in ISO 22156. Making connections in bamboo is tricky. You can either have elements in the same plane, or you can have elements in different planes. And people like having them in the same plane because it looks very nice. So you can have connections that look like this. You could have compromise on the aesthetics and you have something external, or gusset plates, which work very well actually, but most architects will cringe at the idea of using that. They prefer concealed joints that don't work so as well. You can have connections where you have a cross members, very easy to make, not as stiff as the previous ones I was showing you, and maybe that's another aesthetic compromise that you could arrive at. We've included also light cement bamboo frames. And so what does ISO 22156 include? Well, it's not meant for any country in particular. It doesn't have a jurisdiction. It's a model code. It tells people, here are the pieces from which you can build your code. It needs to be supplemented by something called like a national annex that could prescribe limits on species, dimensions, grading practice, and allowable stresses. It's specific to bamboo. It's not some sort of copy over of a timber standard. It is built around thinking the peculiarities of bamboo, and I've put here in speech marks as a product, because when we're using bamboo as a column, we shouldn't think of it as a material. We should think of it as a product. That means it comes with certain sizes and characteristics. And this is based on the work and observations of undertaken as an international team based on experience and experiments over decades. So it's far superior to the other bamboo standards that exist around the world prior to it. It does need to be, for it to work properly, it needs to be preceded by grading that you have to do to the other standard we mentioned. And much of what we've done for it to work is in terms of things that we didn't think made any difference to the product itself or the standard. We borrowed some timber standards, but that was mainly for experimental procedures and statistical analysis. What we think that the methods of design are familiar to most engineers, so we hope they would make life fairly easy. And we hope that if you were to adopt it as a national standard of code, you could convert it into span tables or something like that, which would make life easier for engineers to adopt it, other than instead of sending them to the drawing board and work from scratch. What do I see next in my future? We're going to continue working in developing standards for engineered bamboo. We will work in revising the bamboo standards for culms because they need to be revised and updated. I'm going to continue doing my work around grading and how to characterize bamboo culms, because continuously people are approaching us about, oh, I want to use this bamboo in this part of the world, or this bamboo this part of the world. And we want to guide them on how to go about characterizing them. Work needs to be undertaken with connections. At the moment, connections are, in my opinion, far from satisfactory. We need to look at engineered bamboo products in more detail, particularly engineered bamboo products made with tropical bamboo. Most of the research that's been done with engineered bamboo products has been done in China, particularly for one species of bamboo. And so we need to know if the characteristics that they've found are transferable to tropical bamboos, which seem to be stronger and stiffer. And this other material I've shown you earlier that I mentioned, Pimbu, which I find fascinating. And we need to write manuals that accompany these standards. We are in the process of publishing a manual for ISO 22156. Hopefully within some stage in 2024, it will be published, and it should be freely downloadable from the website of the Institution of Structural Engineers. And yeah, well, we have to disseminate these standards. We have to work towards their adaptation and adoption. And one thing that is very precious to me and very close to my heart is we need to teach structural design with bamboo to future generations of engineers. You might say, well as architects, but in my experience, schools of architecture are well ahead in trying to engage with novel materials. And it's we engineers who tend to be a bit more cautious and reluctant. Okay. And that's the end of my talk. Thanks for listening. And I think I've been spot on 40 minutes since I started. Thank you.
Thank you, David. Thank you so much. It has been a great presentation, an amazing material, stunningly beautiful. It has all these properties that you have described, and I'm sure that yes, you have so much more to tell about this product that we could be here for hours and hours. But we will leave all those details for later. Now we will come to some of the questions that the audience had. I will start. What are the main barriers preventing the bamboo being used more widely in Europe?
Well, thank you, Monica. That's a really interesting question. In Europe, why isn't it used more widely? I think there are many aspects to it. Firstly, we have very little need for using bamboo in Europe because we've got a very established, mature timber sector. So you would say, why would I use bamboo when I've got timber at a better price? So we don't have a real need for it. Secondly, we don't have sufficiently developed supply chain that is local to us, so we'd have to import it. Importing bamboo culms is inefficient. It makes the price of bamboo higher than it would be otherwise. Its carbon footprint becomes quite high because so little fits into a container because it's bulky. so the environmental credentials get a bit damaged by the shipping of it. If you had when you ship engineered bamboo, that's not so bad because you can fit a lot more of it in a container. And so we do consume bamboo. I mean, if I show you the floor behind me, the floor of my house, it's made of bamboo. But it's into markets where it can compete. Structural applications of engineered bamboo are a lot more expensive than the glue lamp over my head. So when you go into the market of structural things, people are very much governed by price. When we're in the market of finishes, then people are other criteria come in, and that's why my floor is made out of bamboo, but not the roof above me, because it's a different market. Could it happen? Yes, it could, but it would probably require also that these standards for bamboo products are a lot more developed, so that people importing the products are confident of the product and say, yeah, this is equivalent to timber. Let's use it.
So one of the main limitations is the large supply chain that we need for supplying this type of material to Europe. But what if it was produced or harvested in Europe? Would that be feasible in the same amounts as we could potentially do with timber?
Yeah, it's a very good question. And the answer is we're working towards it. I say we, not necessarily me as an individual, but people in the world that I know. There's an organization called Bamboo Logic, which is very much around, based in the Netherlands, but they are promoting the creation of a supply chain of bamboo. And I was precisely this morning talking to them. In Europe, bamboo in Europe will never be as big as the bamboo I've been showing you, because we just don't have the climate for it. But in Southern Europe, you could produce decent sized bamboo, which could be converted into engineered bamboo. But even if, despite bamboo growing very quickly, it will be several years before you have sufficient plantations to supply the market. And so even if, we did it fairly soon, we planted all this, it will take a year quite a few decades really, before we have the volumes that could address the market, when we already have a very established industry that produces the timber. So I don't think bamboo is going to be, no, let's phrase it this differently. I don't think Europe is a place where bamboo is going to most play a role. It can, and people are working towards it, and because it can supply very many industries, not just the construction industry, it can supply paper industry and all sorts of other industries. But you have to create it's a chicken and egg one. The people wanting to buy it, but they want to buy very big volumes. And people have to grow it, but they have to be confident that they're going to be a buyer. And so it's while you build that confidence in the market for the farmers who are making this investment, that their product is going to be bought, and for the factories that are going to buy the stuff to know that it's worthwhile investing in the machines to transform the product to make that investment. So I don't think it's happening. The first place it's going to happen in mass. I do think it will happen, but in smaller numbers.
That's very interesting. But at least you say that it's actually feasible. And as you were explaining before, this type of species grow faster. Therefore, for the same amount of land and the same amount of time, you would, I guess, get more amount of volume of material having bamboo instead of having timber. Would that be correct?
It's a very good question. And the exercises I have seen that compare like for like production of materials are are limited. There was the best study I've seen, and there might be a better one out there, but that I've seen was one from China, and they demonstrated that yes, in that context of China, you could produce more volume of bamboo from the same area of land. But what was interesting, and the study didn't go into depth to explain, is that that bamboo that you produce is a stronger material than the one you would produce from that timber. So you have the potential that not only you produce less, you produce more material, the material that you produce, you need less of it to build.
That's interesting. And it's interesting to showcase that as well, to make it at least that information available for people when start making decisions on this. So I will continue with some of the questions. What is your take on cross-laminated bamboo? Does it have the same structural ability as CLT? I'm not sure if you have actually covered this.
Well, I have seen some CLT or CLB, shall we say, made from bamboo. I have not had the opportunity to test it. I don't think it's being made in very big numbers. My experience with laminated bamboo so far is that it's an interesting product. It's promising. It's still expensive. And you have this chicken and egg thing where this is just making it into beams. This is before we make it into slabs. You have this chicken and egg situation where you need to make a very big investment to set up a factory that makes it. So you have to have a very capable supply chain of bamboo and a very steady demand from the buyers. So if CLB is happening in any scale, it might be in China, but I'm not seeing much. I mean, they've recently did a demonstration building in China, a 6-story building. And as far as I know, this is a demonstration building. So could it happen? Yeah, certainly. Maybe my question would be, should it happen? I think there are more urgent questions, more pressing questions than trying to make CLB, which is, can we make glulam, so that's beams, at a price that can compete with timber products or other framing materials, and then we can make it at a competitive price so that we can then make it competitive, and we can then imagine displacing, not timber, because it's not about replacing timber. What we really want to do is replace concrete and steel.
Yes, and timber also
is also a good material. And the problem is, it's not about it being able to displace timber. It's about being able to displace concrete and steel. And that's why prices are one of the really key things.
But also timber itself alone cannot cope with all the demand you might have in the next years.
Absolutely.
So we need
Absolutely.
to support it with other types of materials as well.
Absolutely.
Good. So are there studies about the aging of cross-laminated bamboo?
My answer is I don't know. I don't know if there is. I wouldn't claim I'm in the forefront of research in engineered bamboo. My interest has been, until fairly recently, been bamboo culms. Reason being is because most research within engineered bamboo has been led by the Chinese, and they have a lot of work and research being done there. And I'm far from the cutting edge of the development in here, but I'm getting increasingly interested. And I do know there has been work in studying the aging of other engineered bamboo products, and they are European firms that sell engineered bamboo products that can be used outdoors. And they have substantial evidence that this engineered bamboo product can be used outdoors. But notice I'm stressing engineered bamboo outdoors, not bamboo columns outdoors.
Yes, it's good to be very clear about this. And are you aware of any testing engineered bamboo in Europe? So I guess in China must be more common, but in Europe.
Yes, there has been work of engineered bamboo testing in Europe. As I said, for example, even for commercial purposes, there are European companies and Chinese companies that distribute in Europe that have evidence that their products have been undergone a series of tests. And there has been work in engineered bamboo done here, for example, in the UK. A decent amount has been done. Cambridge undertook some work, University of Bath, just to mention a few.
Good. And we've been talking about Asia, in particular China and South America and Latin America, and the challenges in Europe. And how about Africa?
Well, that's a very good question. At Atelier 1, we are doing some work in Uganda, jointly with a Dutch firm of architects. We would love to see more development of bamboo in general in Africa. It is one of the markets, it's one of the parts of the world that we're expecting largest urbanization in the planet over the next decades. And it would be brilliant to see that they urbanize in a way that is a lot less detrimental to the environment than what we've done in the rest of the planet when we urbanized. I wish more was happening. We need to find paths for them to develop these technologies. And one of the reasons why we went about developing bamboo columns first is that we think, well, I personally think that the bamboo market needs to be developed by stages. And the bamboo column construction is the lowest rung in this development of the market, because you don't have to do a lot of complicated transformation. Using it is labor intensive, but you're doing it in a market where labor is relatively cheap. And so it's the lowest rung in the market. Then you have, at the other end, engineered bamboo. What I think is interesting to explore is, can we imagine ways to transition from using bamboo in the round to all the way to engineered bamboo? How can we gradually help the market mature, create the supply chains? Because you need to create a situation where farmers are confident to grow it. They know someone's going to buy it. The people setting up the factories are confident that they're going to have a supply chain. People are going to be selling them the bamboo. And you need everyone else above that knowing that how to use it, that the product prices are knowable, affordable. You need people who the authorities are not going to say, "Oh no, you can't build with this," and so forth. So it is a process, and how do you get there is one of the things that very much concerns me, and that would be very interesting to be able to do it in Africa. But I don't know if it will be the first market to develop it, or we help them copy over a model that's developed elsewhere.
That's very interesting, and I think that summarizes this whole presentation that you gave us today, and this chicken and egg. I think this is the key takeaway. It's everything about chicken and egg. So how to all of us contribute to move this way, so this material can become more mainstream, because we will definitely need it. So thank you, David. Thank you very much. We have a few other questions still in our in LinkedIn and YouTube. So if you have the time, then maybe you
Yeah.
can answer directly. That would be very much appreciated. Thank you. And thank you everyone for joining our Share Your Green Design Masterclass and for all your questions. So as usual, this session will be posted online. Check our website, shareyourgreendesign.com, and subscribe to our channels to keep up with this and other content that we are constantly sharing, such as latest projects, news, research events, competitions, student work, and job adverts. If you have projects or research that you want to share in our platform, please get in touch with us. And if you have any comments, ideas, or just want to collaborate with us, please get in touch as well. Thanks, everyone, and see you again.